GitOps is one of those buzzwords you have probably heard a lot about lately, but what does it actually mean and why is everyone so excited about it? When I first started exploring about GitOps, I had no idea how much time and effort it would save me. Now I can't imagine working without it. It's completely changed the way I approach automation and manage infrastructure. And in this video, I will break down what GitOps is and how it works, explaining it's different from the usual CI/CD approach and the big benefits it brings to DevOps workflows. And by the end of this video, you will have a clear understanding of why GitOps is a game changer. So the first thing we need to talk about is the traditional workflows. This is where most teams struggle, facing inefficiencies they might not even realize exist. And the traditional workflows are usually based on imperative scripts, which are a step-by-step instructions to configure an application, get it to the desired state. In the best case scenario, there is a pipeline places some parts of the CI/CD process, but they usually require a manual trigger. But even today, many sysadmins still do this manually, and DevOps manually trigger pipelines to update an environment. For example, imagine you are a developer, you have finished your work on a branch, you create a pull request and merge it into the main branch. Then, a CI pipeline kicks in and builds a new Docker image from your chains. This is the most common scenario of a CI pipeline. And now for the deployment process, a sysadmin steps in, SSH into the virtual machine running the service, and manually run commands to pull the chains, update dependencies, restart the app, and that will update the cloud services. Or in another scenario, there is a DevOps that will manually trigger a deployment pipeline to update the server image by providing the image tag, for example, and that will perform the same operation but a little bit more automated. And on the infrastructure side, it's not much better. Resources are often set up manually using the ClickOps approach, where someone clicks around a cloud provider UI to provision the resource. And even teams using infrastructure as code tools like Terraform or CloudFormation still depend on a single engineer to run commands from their own machine whenever something needs to be created or updated. And while this works, this can lead to several problems. First, this approach is not scalable and it's definitely not reliable. Manual processes always lead to inconsistencies. What is running in production might not match what was intended, and there is no built-in version control for infrastructure change, which makes rolling back risky and messy. And when something breaks, troubleshooting can take hours, if not days, because there is no single source of truth to rely on. And that's where GitOps comes in. The main idea is very simple. GitOps makes Git the single source of truth for everything. Instead of manually managing infrastructure and applications, you store the declarative descriptions of your desired state in a Git repository and automate everything to keep production in sync with what is in Git. So if you need to deploy a new application, provision a new resource, or update something existent, all you have to do is to update the repository and the system detects the change and applies automatically. No manual steps, no extra effort. And here's why GitOps works so well. GitOps builds on something developers already know and use every single day, which is Git. You're already using Git for your application, right? GitOps just extends that same principle to everything else, your infrastructure, application configuration, and even operational procedures. Everything is stored in Git, making changes easy to track, test, and roll back if needed. And any change you make is automatically synchronized with your live environment. So that simplifies your workflow and ensures consistencies at all times. You automate your entire system from the application to infrastructure changes. Everything is declarative using infrastructure as code tools like Terraform, Pulumi, or CloudFormation, any other infrastructure as a code tool. And it's way more secure because there is no manual change involved. And now let's talk about how GitOps is implemented. There are two main strategies to implement GitOps, the push-based deployment and the pull-based deployment. Both have the use cases, but one of them is clearly the better approach. Starting with the push-based deployments, this strategy works with popular CI/CD tools like Jenkins or GitHub Actions. The CI process here is the same. You have your application source code and configuration files like Kubernetes YAML file in a Git repository. When you update the application code, the CI pipeline kicks off and builds a new Docker image. Then DevOps updated the environment configuration repository, specifying the new image tag, for example, and that triggers a deployment pipeline which applies the changes to your infrastructure, which is being represented by a Kubernetes cluster in this case. But that could be anything like kubectl, a kubectl apply, a Terraform apply, or any CLI tool that would apply the changes to your infrastructure. And that sounds simple and straightforward, right? But here's the problem. The pipeline only runs when the environment repository changes. It has no way of detecting if something in the live environment drifts from the desired state. So if a change happens outside the pipeline, the CI or CG will not know using this approach. And that's a big limitation. And this is where the pull-based deployment shine. It works similarly to push-based workflows, but flips on how the deployment process happens. Instead of waiting for an external event like a code push, the pull-based workflow introduces an operator. And for example, FluxCG, ArgoCG, which are very popular operators in this industry, the operator continuously monitors the desired state in your Git repository and compares it to what is actually running in production. And if it detects a difference, it automatically fixes it by updating the infrastructure to match what is in Git. So just like the push-based workflows, it applies the change when the environment repository is updated, but unlike the push-based workflows, it also detects unexpected change in the live environment and reverts them to match Git. For example, if someone manually updated the infrastructure, say deletes a deployment in a Kubernetes cluster, the operator notices the change and immediately reverts those changes and ensures everything matches the environment repository. And this approach ensures every change is tracked in Git, making Git the single source of truth. It also prevents direct manual changes to the cluster, which improves security and consistency. So whenever possible, the pull-based deployments are always the better choice. They ensure your environment is always secure, consistent, and in sync without relying on manual trigger. It's a more reliable, automated way to manage your infrastructure, and it is why GitOps works so well. And just to wrap up, GitOps is a simple but powerful way to manage infrastructure and deployments using Git as the single source of truth. The key principles are declarative. You define what your system should look like in Git, like saying I want 2 replicas of these services running, and the automation takes care of the rest. It is versioned, every change tracked in Git, so you always have a full history of the change. If something goes wrong, you can easily roll back by just reverting the commit. It is automated. Tools and pipelines keep your system in sync with what is in Git, removing all the manual process, all the manual steps involved, and it is continuously reconciled. So if something changes outside of Git, like someone manually tweaking the infrastructure, GitOps detects and fixes it automatically. And that's it for this video. Thanks for watching and see you in the next one.